Hello, and in this video, we're going to talk about relational fields. More specifically, we're going to talk about database performance, and we're going to talk about how we can use our tracing data to really investigate what's going on in our databases and understand how and where we can optimize. So let's dig in. So first of all, we're going to have a look at our basic tracing system. We're going to look at specifically how many spans we've got that relate to a database statement. That's going to give us, across our entire system, all of the spans that hit a database. So we know that we've got about 98,000 individual database spans that are part of this system. But what we don't know is what those database statements are. So we can go a little bit deeper and actually look at, for each of the different types of database statement, how many are each of those. Now, if I scroll down, we can see that the top result for our database statement is actually hget. Now, I know that that's not a database query, so I can quickly get rid of that by hitting here and saying I don't want hget. So let's go a little bit further now. We can see that the top database query that we've got against our database is actually select star from products. So if we were trying to optimize our database, that would be the first place that we would go, but ultimately that doesn't tell us the full story. It doesn't tell us that that is the one that's causing the most performance issues. Now, a good place to start with performance optimization is actually looking at duration of these. Now, if we were to take the P99 duration, so that's taking the percentile of P99. So if we look at the P99 duration, we're going to see which ones the longest ones of these are. So let's rerun that query. So we can see that the longest database query that we've got is actually these two to do with a select star from products, where category is in a list. And then we've got select star from discounts. Now we can see that they're around the same performance, but there's a lot more of these ones here. So let's dig in a little bit and have a look at that individual one. Okay, so now we've got a list of only those ones. And we know that we've actually got around 15,000 of them. They're taking around 205 milliseconds each. So what do they come from? Where are these happening? Now we can go in and we can click on each one of these and look at an individual trace, and we can work out that the entry point that a customer made was /cart/checkout. We can then go back and we can look at another one of these and look at, say, let's see what that one is. Oh, great, that one was cart checkout as well. Now, is it only cart checkout that's actually causing these? Actually, no, look, we've got /cart as well. So if we look through these, we don't know where these are coming from. We do know that they're fairly slow and they've taken up a lot of space in each of these. Now, this is where we can use something called relational fields to see what the user is actually doing. So in our group by statement up here, what I'm going to do is I'm going to do root.name. And I'm going to put that at the start. I'm going to reorder these. And now let's have a look. We can see that of these individual queries, the most amount of calls are made when we hit /product/ID. Now that doesn't make sense to me why we'd be doing an in statement. It's probably just that we're reusing a query. That gives us an idea of something that we can optimize, but more specifically, something that we can target so we can make a change more safely. Now, this is something that we like to call ODD, or observability driven development, or more specifically, using our telemetry signals during our development lifecycle to be able to influence and make changes more safely. That's one example of using relational fields. We're using a root to be able to see what the entry point was. There are lots of things that you can do with it, and I'm excited to see what you're able to do with this.